Okay, in this example we're going to look at what we call Venn diagrams. So in this example it's just going to involve two sets. So the question says there are 59 students taking data management, so that's going to be one set. So A equals the set of all students taking data, and B, so the rest of the question says there are 93 students taking advanced functions, so B will be the set of all students taking just advanced functions. So we know that the number of students in A is equal to 59, and the number of students in B is equal to 93. We're also told there are 25 students taking both data management and advanced functions. So this is what we call the intersection. So this symbol right here means intersection. So the intersection is just anything, so it's the set, anything that's in both. So the set of all students taking both data and advanced functions. So the number of students in A intersect B is equal to 25. So some of these 59 students in A are also in B, and similarly some of the 93 students in B are also in A, and it turns out there's 25. So now we want to illustrate this situation with a Venn diagram. So the way we're going to illustrate with a Venn diagram is we're just going to use two circles to illustrate the sets. So this will be set A, and this will be set B. So notice there's now sort of three parts to my diagram. This part here, which just has A, this part here, which just has B, and then I'll do this with another color. This part here, which is both A and B. So now we're just going to put the number of elements in each section. So this part here includes both A and B, so this would be the 25. So 25 students go here. Now notice, now we're going to look at A. So A is, I'm circling A. A is made up of this whole circle here. Well, there's already 25 students in this blue circle. And we know that the total has to add up to 59. So what's left over here? Well, 59 minus 25 is 34. So there's 34 students that are just in A. So the total in all of A is 34 plus 25, which is 59. And then similarly, I can use black for this one. This is B. So the total number in all of B must add up to 93. We already have 25 that are already in B. So 93 minus 25 is 68. Minus. So the 68 will go in this section. So that's our Venn diagram. And now oftentimes with a Venn diagram, you just put a box around the two sets, and this set kind of represents what we call the universal set, or S, And any students that kind of weren't taking either advanced functions or data would go outside these circles and in this box, but we're not told any information. So now you might ask, okay, what's the Venn diagram useful for? Well, it's a nice visual representation. It also helps us to answer other questions, like, for example, what if I wanted to know how many students are taking either A or B? So how many students are taking a math course? One of these two math courses. So what we call that is the union of A and B. So the union of A and B is the set of students taking data or advanced functions, or both. So basically they're taking one of A and B or both of A and B. So basically you're just going to add up all the numbers here. So the number of students in A or B is equal to 34 plus 25 plus 68. Which is 106. So 106 students taking either A or B or both, and that's what we call the union. So A or B is, maybe I should have wrote that. So this is what we call the union of A and B. So it's anything in A or B or both.